So thank you all for surviving to this day of so nice talks. As Justin said, we felt that we should introduce some concepts on the safety of recycled cellulose-based materials to this set of speeches today. So I will give some very light concepts because it's rather late on the day. Different types of paper and board, some notes on recyclability and the composition and what happens in the recycling chain. Brief on potential hazards and the impact of recovery and the recycling process. And then a little bit on the criteria that is being used today by industry to assess recycled cellulose-based materials. And finally, very briefly, some notes on alternative approaches that come a little bit along with something that I think Justin said in the morning, that in real life, in real materials, we have mixed hazards, mixed chemicals, and not one by each one. So we may need to have approaches that can evaluate these mixtures. So when the several substances are present together. So when it comes to the different types of paper and board packaging, we have many different types. Like, for example, glassine paper that is made out of 100% virgin paper, but often people think that this has some kind of silicone coating, which has not. We have paper that can be coated with silicone. We can have composite cans. We can have cartons for liquids, which are multi-layer. We can have folding cartons, corrugated board used for transportation packaging. And more in the market, we have these coated boards that are used for applications where most often plastics have been used. So what does this mean in terms of the composition and the recyclability of these materials? So as I said, glassine is almost 100% virgin pulp. Then we may have a test liner that is 95% recycled pulp already. Then we may have different coatings, like in this case where we have the two faces of the paperboard is coated, and which means that we have only 60 to 70% that is chemical or mechanical pulp, and the rest being other materials like fillers, binders, starch. We may also have barrier coatings, and therefore we end up with a material that is not anymore 100% cellulose. So the indexes of recyclability that Igor mentioned this morning will decrease. Recycling needs a chain, and we have also listened today about design for recycling, 1D. And, but this is not enough. If we combine design for recycling with capacity to recycle, we end up with a recyclable material. But this is not enough as well, because we need, again, the consumer behavior to make the material recycled. And this is what we want. This is the target for in the scope of the circular economy, of course. And I just put here some notes on something that is on the market, and there is legislation, quite old, but only very recently industry started to use it, is the marking, identification of the materials, like we have in plastics, and everyone knows in plastics, but much less people knows that the similar codes exist to identify different types of cellulosic-based materials, identifications that has the objective to make more easy separation when it comes to recycling. Yeah, Igor also mentioned this morning that there are some cycles, expectations, recycling cycles, the number of recycling cycles. When we should be aware of the paper cycle, so we start with wood, we then may have different type of pulping processes, we may have mechanical or we may have chemical. Then we will have a paper machine where the different layers of paper or paperboard are prepared. We have then specific treatments at the end to drain, to dry off. Then we have or may have some calendaring, some coatings, depending on the type of application that we will have. And then we have an entrance of the recycled fiber that comes here. And so this cycle and this machine basically runs underwater. So this very much limit or determine what can be done in terms of recycling. We should be aware that the fiber size is becoming less and less decrease in size, and therefore the potential for recycling also decreases. So if there is this limitation, why recycled paper? And I mean, why recycle paper for food contact materials? And also, Professor Langowski has already pointed out in the area of plastics that food packaging sector uses such a high amount of percentage of the material that we cannot reach targets if we don't recycle for food contact materials. So there is this proposal for packaging and packaging waste regulation that sets these targets for recycling, and that will grade the materials according to the recyclability score. We have already seen this a little bit. More and more non-recyclable packaging are subject to very strict extended production responsibility fees. Some countries have bans on non-recyclable packaging and are foreseen in more countries. And right now, fiber-based packaging has already quite higher recycling rates than other materials. So this is why now there is also a trend, an effort on making recycling paper for food contact. Of course, this brings hazards, and like in plastics, we have a wide range of chemicals that can be present as contaminants that may origin from non-food contact materials that are mixed in the stream, chemicals from other materials, printing ink components is, I think, yeah, Igor mentioned this, and he has explained some de-inking processes. We may also have degradation products of raw materials, of polymers that are present, and other additives. different from plastics, where because of the high temperatures that plastics are processed, which are not observed in the cellulose-based materials. In this case, we need also to look for microbiology issues that can be raised, because, as I said, basically we put water, we take out water, and mild treatments are typically used. However, because of this general interest in using more cellulose-based materials to replace plastics in many applications, we are observing the use of other chemicals that are used to treat the paper, to treat the fibers, to improve the barrier properties and the usability of these systems to other food products. So it can be wet end, non-perfluor chemicals, sizing agents. It can be coatings with thermoplastic materials. It can be modification of the surface, chemical modification with hydrophobic treatments. And it can also be using nanocellulose, micro or nanocellulose to densify the material layer, and with that increase the barrier properties. So with these new substances, new treatments, we do have new migrating substances that should be known and assessed. And we are running a project within a cost action and within a national project, in fact, as well, on assessing these chemicals that are being used to improve the barrier properties and how safe these substances are. Just a quick note that we have spoken this morning about microplastics, but when we are using micro and nanocellulose fibers, we are kind of having the similar problem, because these fibers are also being dispersed and in the environment, and we don't know still very well the effect that they can have. So these days, paper and recycled paper for food contact material is used in rather limited applications, typically in short time contact, like pizza boxes and so. But there is a trend to make these more with wider applications. So some contaminants are very, very strongly bound to the fiber or to the pulp. And this depends on a number of factors, not only on the fiber itself, but also how the fiber is bound to each other. And therefore, we, like in plastics and like Diana mentioned, we also need here proper extraction procedures for guarantee the decontamination in order to be able to reuse it to food contact. What I can observe is that in this area, more than a control of the input, a great effort is put on specifications and control of the output. I think this describes what I think the situation has been right now, but what I think also is that is changing, and sorting and control of the input is becoming more and more important. Like in plastics, a similar approach is foreseen, and we have three main areas, three of processes that are that determine the usability, let's say, of the recycled fiber to food contact. We have the prep processing, where we have how the collection was done, separation, pre-cleaning. Then we have decontamination processes, and Igor has mentioned and talked about this. And then we have post-processing operations, how the fiber is then converted into a package, and the type of application, more critical, more demanding, that we may have for that material. And therefore, the source and origin of the recovered fiber, the efficiency of potential contamination removal of the process, and as I said, the requirements of the intended use for the application are to be considered in this evaluation. Very briefly, industry has this standard that was reviewed. It's an old standard, but it was reviewed in 2013, that provides standard grades of paper and board for recycling. And they determine what are the prohibited materials, so materials, papers and paperboards that cannot be there if the material is intended to be recycled for food contact. And also a second group of unwanted materials, so materials that are not suitable for the production of paper and board. So there is acceptable a certain level of 1.5% can be there if it is to be recycled for food contact. Then there is a classification into 5 groups, and I will not go into further detail. You can then read. Basically, as you understand, we go from a more refined group with better sorting, with higher quality already, versus the first grades where magazines and newspapers, for example, are there. So about the criteria, often we face with requests or answers, questions about this in our laboratory. Paper and board is also included in the regulation 1935. So the requirements, specifications set there are also applied, including good manufacturing practices, traceability. However, although, as we know that in plastics we have specific regulation for packaging, for plastics applicable to food contact, in this case we do not have. And so we don't have harmonized legislation, and what is done is relying on specific national restrictions, like existing in Germany, in France, and the Netherlands, just to mention a few, which can help us with composition and migration limits. Compliance declaration is a concept that it was defined for plastics, but more and more also is defined and used for paper and paperboard for food contact. So this is also something that often industries forget, and that all the composition, all the information that is needed to verify compliance needs to be stated in this document, the document that aggregates all the information needed. Then we have the consideration of risk analysis, because as we have lack of non-harmonized legislation, because we have recycling, so the risk of components that are hazards need to be considered in a much more strong way compared to virgin materials. So just showing that we have some framework of documents that can use to evaluate the recycled material. So we have industry consortium guidelines. We have this Council of Europe technical guide. We have the BFR recommendations that, although are recommendations, they have the strength of a law. And we have also FDA, again, just to give some information on what is more commonly used, but is not a comprehensive list. I will jump this. I would like just to highlight the BFR because here we find a very comprehensive list of the substances that can be used to produce food contact materials, and they cover not only the raw materials but also information for special papers, refining agents, and production aids. So this is very important to consider in not only for virgin paper and board but also for recycled, of course. This is a table where we tried to condense. We took this from the CEPI guidelines, and this is to give you an idea on the requirements for testing non-intentionally added substances in paper and board grades that are intended for food contact materials and from any source. So these substances need to be tested in all cases. And there is a second table with the similar information, but when the material is coming from recovered pulp. And so you can then see the type of testing that is needed, and I don't go into further detail now given the time restrictions. What I would like to point out is that although in plastics, again, we have a harmonized, so we have a complete body of information. For paper and paperboard, we do not have. So we need to combine different pieces, let's say, to have a complete or a more complete puzzle. And for example, in these CEPI guidelines, recently they included some restrictions on mineral oil, saturated and aromatic hydrocarbons. That is something that is recognized now as something that may be a concern, so something that should be looked at with more detail. But then, recently in 2021, the Council of Europe included another piece of the puzzle that is some restrictions related to the recent opinion from EFSA on perfluor alkylated substances, which is very relevant for paper, and in this context of doing treatments for paper to become better barrier. So this is to illustrate that dealing with safety of paper and board, we need to go here and there to pick up the different things that need to be addressed. Some information on declaration of compliance. So for those that are not familiar, the different types of information that the declaration of compliance should have. And I'm not going into the detail. You are able to read all this. And I would like to finish with an alternative approach for safety evaluation that, we picked some published information to illustrate. So as I said, measuring the potency for toxicity of the migration, and not focusing on chemical identification and chemicals determination. So instead of focusing on this analytical approach, we can focus on the effect that that migration may have when the food is ingested, if this migration was into the food. And this is because, as we know, the toxicity can raise, as I said before, not only from one single substances, but from the set together. And not only the unknowns that we target when we go to analyze and screen these NIAs, for example, but also the other components. So we have this synergy effect. So it's a very valid approach to go into the complete evaluation on what migrates. And these papers illustrate how some bioassays for some human relevant endpoints like oxidative stress, inflammation, cytotoxicity, genotoxicity, and immunotoxicity, and in my perspective, very, very much important, endocrine disruptors. And we all know that we have these plasticizers cloud, let's say, because they come from not only from plastics packaging, but from different applications that we have in our homes, in our classrooms, all over, and also in printing inks. So paper and the first results that we get in this project indicate that paper has plasticizers that are not authorized, for example, because there is no positive list for this anyway. I think that this endpoint is particularly relevant, and this approach is something that we should go and focus more and more, maybe parallel to the analytical approach. And Diana spoke very well about the challenge test that is used today for plastics. And this is my last slide. And I found only one paper that already used a similar approach on a challenge test, but to evaluate the recycling process to produce recycled pulp, in this case for adult paper diapers, not for food contact materials, but that means that already thought about using challenge test in the EFSA way to paper and board. Okay, so with this, I thank you your attention. I try to make it on the time, and if you have any questions, I'll be happy to answer now or later. Thank you very much.